Voyager's pictures are the best views we are likely to get of Neptune for a very long time. The dark cloud is Neptune's equivalent of the great red spot on Jupiter. A Neptunian storm cloud with a bright center, like an eye. Ribbons of white cirrus. Voyager homed in on the faint rings of Neptune. Here, the planet's bright globe has been blocked out to show the rings better. Pluto, only discovered in 1930, is never well seen from the Earth. This is the best Earth-based view of the planet and its moon, Charon. The Hubble Space Telescope shows them separately for the first time. Pluto is an icy body smaller than our own moon and probably similar to Neptune's moon, Triton. Its moon, Charon, is half its own size, and at times the two can eclipse each other, as in this simulation. On their way out of the solar system, the two Voyagers are still sending back information about the space around us. They are now approaching the boundary of the solar system called the heliopause, where the gas flowing out from the sun finally meets interstellar space. Eventually, we will lose touch with the Voyagers as their radio signals fade out with distance. But it has been calculated that 40,000 years or so in the future, one of the Voyagers may pass within sight of a dwarf star in the constellation Ursa Minor. If we could ride on Voyager with a telescope, this is what we might see. By then, of course, humans might already be out exploring among the stars. Their first call would be at the star closest to us, Alpha Centauri, which actually consists of twin sun-like stars in mutual orbit, accompanied by a smaller and fainter red dwarf, Proxima Centauri. There are no planets around Alpha Centauri that we know of, but astronomers think that other solar systems may be common. The wings on either side of this star are thought to be a band of dust and gas forming into new planets. The star itself has been blocked out, and the colors are artificial. This computer simulation shows what the star might look like close up. Planets are thought to be forming from the spinning disk, like they did around the sun. New stars are being born all the time in places such as the Orion Nebula to replace those that grow old and die, as our sun inevitably will. Our sun began shining nearly 5 billion years ago. During that time, intelligent life has arisen on Earth. Currently, the sun is in stable middle age. But when its hydrogen fuel starts to run out in a few billion years more, it will swell up into a red giant up to 100 times its present size, swallowing the inner planets and ending all life on Earth. As As it dies, the bloated sun will lose its outer layers, and its remaining core will shrink down to a tiny white dwarf. Like the one at the center of this nebula. Even 5 billion years from now, when the sun has died, there will still be plenty of new material to make more stars in nebulae such as these. And what will be the fate of the rest of the universe? Astronomers are now discovering a remarkable fact. The visible galaxies represent only a small fraction of the total mass of the universe. Most of the mass of the universe is contained in the form of dark, invisible matter that does not show up on photographs. If there is enough of this dark matter, its gravitational pull could affect the fate of the whole universe, slowing down the current expansion and eventually reversing it, so that all the galaxies fall back together again. Perhaps, billions of years in the future, there will be another Big Bang, creating another universe with lots of new wonders to explore.
Science Frontiers continues on TLC.
On them.